In Math 1108, we'll be doing section 1, 2, and 4 in chapter 2. We'll be skipping topic 3 and topic 5, and this will reflect on your chapter test as well. So if you took Math 1103, you recall we did do some work with graphs and equations of lines, and we may not have done much with inequalities, but we'll be picking up and going over these as review. So with that in mind, let's get started. And when we think of a graph, remember we're thinking of two number lines, a horizontal number line, which is our x-axis, a vertical number line, which is our y-axis, and then units to the right here are positive, to the left are negative, and above are positive, below are negative, and we divide the plane into 4 regions or quadrants. So this is the first quadrant, the second, the third, and the fourth. Often they ask us which quadrant is something in. And remember, we're dealing with ordered pairs. And we always start with our x item first. We'd go from 0 either right or left, and then the y up or down. And that brings us to these various ordered pairs. Now, of course, any ordered pair in which x and y are both positive are in the first quadrant. Here, if the x is negative and the y positive, it's the second. Here, both coordinates are negative. Here, the x negative is positive, the y coordinate negative. And then, if they're on the line, like we see right here, that is a 0, 3. This is on the y-axis, and you might recall this is your y-intercept in the form 0, b. And then here we see the form a, 0, which is your x-intercept. This would be on the x-axis. Okay, so this is a little review, and if you need more work on this, you can read the textbook a little more carefully. And we'll be looking at writing equations, and there are some general background things we should look at and remind ourselves of. That if an equation is in the form of ax plus by equals c, we thought of this as standard form. And if we solve for the letter y equals mx plus b, this was in slope-intercept form. Now, here in Math 1108, we will look at equations like this. This one is in slope-intercept form, where the slope is a -2, and the y-intercept is a +3. But we'll also be looking at, and that is a line, a straight line. We'll also be looking at equations like this, where we have y equals x to the second power. This is an example of a parabola and is not a straight line. So we would say this equation is not linear. This one is linear. And they'll be giving you examples, some of which we covered in an earlier course. Let's look at example 1. Which of the following are solutions of this equation? Well, again, recalling items that we did in the past, perhaps, might be useful. We said a t-chart is often useful. And we're wondering whether 2, -1 is in fact a solution for this equation. And you might say, well, how do you do that? Well, you take your -1, which is your y term, and then take your x term, put it where the x variable is, which will be a 2 there. Is this true? Well, a -2 times 2 is a -4. A -4 plus 3 is a -1. So yes, this is a solution. Now how about 4, 7? Well, you'll put a 4 there now, and then a -2 times 7. Well, let's put them in the right order anyway. That'll be better. Our y is a 7. There you go. And then -2 times 4 plus 3. This is a -8. A -8 and a +3 is a -5. And that does not. So this is no. And I'm sure this is what they're talking about here in the text material. Now, they are mentioning in this paragraph that these equations have an infinite number of points, ordered pairs, that would be solutions. And that was just one that we said was working for that. And the graph is an equation of one of these solutions. Now for number 2, they want us to sketch the graph of this. And for this, they want us to use a t-chart, which they have right here. And you can put various points for your x value, and then you solve to find out what would your y value be. So these are sets of ordered pairs that make this equation true. And if you plot them, you see you have a straight line. Now notice right here where your point is actually on the y-axis, that as you draw this line right there, we say this point that is in the form of 0, b is your y-intercept. Now we didn't plot the x-intercept here, but as our graph came through the line, we saw the x-intercept would be the point where the line crosses the x-axis. Now we don't know what that point is particularly. If it's right on the grid mark, it's easy to pick up, but it's not. It's somewhere in between. We could figure it out algebraically, but Here we're just illustrating what the intercepts are. Now, I think they'll do this, but we want to do it ourselves. If you had a graph that you're sketching yourself, and they've asked you to graph this equation, we had said in an earlier course that we would plot the y-intercept, which is 1, 2, 3, 4, 5, a dot right there, and then we would plot the slope, which is a -2 over 1. Now there are a number of ways to do it. I'm suggesting that you go over 1 unit, which is your run. Remember, slope is y units over x units. So we do, since it's negative, we're going to do our x unit to the left and then up 2. And then we make our line. And you see we get the same equation, the graph of the same equation, by doing it this way. In fact, you can see it right here. If you go over 1 and then up 2, and then there's your line. So the typical way, or the beginning way of making a graph, is to plot a series of x and y points. Or, if you know, if it's in slope-intercept form, you can plot the y-intercept and then plot the slope. Again, we did this in Math 1103. Let's go on. Now they are showing how to solve for the x-intercept here, where if y is 0, then what would your x value be? So you solve for x. You can transpose this and then divide both sides. So it's 2.5, or 5 over 2, or 2.5. Okay, let's go on. Example 3. Find the x and y intercepts of the graph. This is a parabola, and then sketch the graph. Okay. Well, let's look for some strategy to do this. When you are graphing equations that are a parabola, that is to the second degree here, you're going to need a number of points because they're not a straight line, but going to end up as a curve. And to get your intercepts, it's going to be, you're going to need 2, where x is 0. This will give you your y-intercept. But then you're going to get 2 x-intercepts. So you're going to need 2 zeros. That will give you your x-intercept. Remember, this is 0, comma b. That would be a y-intercept. And then you're going to need a, comma 0. And another a, comma 0. And you might not know where these are, of course, until you put it into the equation here. And then what points do you put here? Well, you want to put some negative values for x. You're going to put a 0. And you put positive values for x2. Spread them out a little bit so that you start to get enough points so you can sort of sketch your graph in there. Now the nice thing about MATLAB is they do it very well, but see how nice and smooth that one is. So what are then your y-intercept here, and what will your x-intercepts be? Well, we can pick them out from the graph. This is your y-intercept right here, and you can see it right down there too. And your x-intercept, we see one of them right there and the other right there. So this will be a -2 and a 4. There's your -2 and there is your 4. Now a little later in the course we're going to be finding other things about graphing parabolas. The nice thing about MATLAB is there is a tool where you start putting a couple of points in and it draws it for you. But you'll be practicing that as you do MATLAB. One other thing before we leave this page is that if you are plotting points and they don't seem to go in sort of a nice curve, then those are errors, because the parabolas will be nice curves. And as you develop your t-chart here with your various values, again, you'll check your work to be sure, they are running in a smooth curve. Now we're asked to sketch the graph of this, and as we look at this is a radical, and we're looking at x plus 2 as the radicand. Now you're going to think of, well, what points do I put on my t-chart as I start to gather points to find out what y would be? Well, the answer here is, first you have to find out what values are in the domain of x under these circumstances. And what we're saying is you can't have anything lower than a 0 under the radical sign, because as soon as it becomes a -1, this is not a real number answer. So what we have to do here is equate this to the inequality that x plus 2 is greater or equal to 0. So this becomes x is greater or equal, transpose the 2, and that becomes a -2. So the lowest value you can have for x, to still keep this a real number, is a -2. So that's the number you put in your t-chart. And you could put other values there. And that's not this one, but we'll get to it on the next page. But you want to try to make these perfect squares so that you get nice numbers out of it. So let's just try a few. So if this is a -2, this then becomes a look. So we start with a -2. Now they did use a 5 there. They did use a 0. I guess that would be alright, because that would be your, this is your your y-intercept there. And you get this sort of curve. Now, often in Math 1108, you are asked to pick out something from multiple choice. Which graph is it? They're going to give you 4 graphs, and you pick out the one that matches up. Now, let's analyze this just a little bit so we can learn something from it. So this is y equals x plus 2. So when we have a negative 2 there, that's the lowest, and in a sense that's our x-intercept there. And looking at this formula, x plus 2, do you notice that what happened, in a sense, to what we see under the radical sign, a plus 2, when it pops up on the graph, it's at a negative 2. So kind of keep that in the background as we later will be analyzing some of these formulas. You might wonder if you had y equals the square root of x minus 2, where would this one start? If a plus 2 started here, that is at a negative 2, where do you think this one would start? If you had a graphing calculator, you might put it in, and you would see that it started at a 2. So an interesting thing is going on with the signs that we'll be talking about a little later. Here they're giving us some more information that we've already covered about the intercepts and equations. The x-intercept, the y-intercepts. Notice in parabolas we're going to get 2 usually x-intercepts with only 1 y-intercept. Not all the time, but at least most of the time. Now we're going on to reading graphs, and these are always a little tricky because these points may be hard to interpret. What you want to do on your graph is make them as big as possible. Look at the parameters that are on the sides. And another little observation that we see here, this little wiggly line at the base of the y-axis indicates that a whole bunch of data is not included, or because there are no data points down here. So it's saying this would be 0 normally, and then just this little bit already goes to 1400. That's just a little something to look at. So here are some questions. What was the value of this on day 11? So you would go to day 11, go up to here, and then this one's right on the grid line, and you would just go right over there and read it. Okay? So the ordered pair for that day would be 11, comma, this. And that's what they're showing you down here. And then for day 17, the same. At least these are right on the grid lines there. And then on what days was the value of the index above this? Well, here you would look over on the right, or I should say the left, where this is, and then look at the coordinates and you would list them. Let's take a look at this one. After reading this, I realized that I would have to read it all to you. You would need to study, but suffice to say that if you look at the red line that we spoke of in Chapter 1, which is revenue, the blue line, which is cost, anytime you are above the blue line with your revenue, you're making a profit. So you can kind of delineate when your profit is being made. And by reading this carefully and then interpreting the graph, you can pick out the answers, and of course that's what they want you to do. Okay, now in example 7, I believe there is a graphing calculator available to you, and if those of you who have TI-83s and those graphing calculators, you can plug this in. Here they're giving you examples of what to do. First, setting up the viewing window, which if you have a TI-84 or better, you can easily do that. And then let's see, following those instructions, you get your window set up, then you type this in. Notice this was your original equation. To put it into a graphing calculator, you need to have it as y equals something. So if you divide everything by 2, it becomes this. And then you hit the graphing button, and you'll be able to do this in your math lab because I've seen students do it. Your curve looks like this. Now notice you can pick out your x-intercept there, a y-intercept there, and your another x-intercept and another x-intercept. And it tells you that you can stretch it out a little bit and maybe get those points a little more carefully. Again, I'm not sure exactly what is available on this, but I've done the study plan for this section, and I believe it can be done. And often, again, they're going to give you multiple choice. You pick out the graph. Now notice this was to the third degree, x to the third. So this is very typical of x to the third graphs. Parabolas were typical of x to the second, and x to the first, and were just nice straight lines. Okay. Now, as we look at example 8 here, it says use a graphical root finder to solve this. Well, this is to the third degree, so you're going to get this typical type of graph, and notice it crosses the x-axis there, and there. Often when they ask you to do something like this, they'll say find the zeros. Well, it's equaling this equation to 0, and they're thinking, well, what values make this side of the equation equal to 0. And it's where the graph crosses the x-axis that are solutions for this. So we're looking for the x-intercepts. And again, depending upon what your instructor wants for this. So as we look at example 9, here you would read it carefully. This is the equation, and they're saying where x is equal to 2, that corresponds to the year 2002, and you put this in a graphing calculator, and they're looking for where x is 2. And I'll leave that to your instructor to give you specifics on it. In past years, we would ask students to do certain exercises, and you can see the kinds of things they would ask and are probably in your practice and quiz me's. State the quadrant. You could probably do that pretty easily. Determine if these are ordered pairs that make the statement true. Sketch and graph these. List the x and y intercepts. And again, x and y intercepts here. And being able to interpret and pick out points from the graph and that type of thing. So hopefully this is helpful, and you will have lessons, of course, in the class where the instructor gives you specifics of what they feel will be important. These are some general comments on your textbook.